Okay, so now what we're going to do is we're going to finish up section 7.3. Before we worked on can you find the interval, okay, here's all the given information, can you find the interval. Now what we're going to do is we're going to say, all right, we don't actually want the interval, but what we want to figure out is how many people do you need to ask? What's the minimum sample size in order to get a confidence interval, okay? So the interval formula is p hat minus z star, and then it's big square root p hat q hat over n less than p less than, same thing on the right but with a plus sign. So what we're doing is we're working with the margin of error. This part here is the margin of error, okay, just right there. So if the problem gives us the margin of error, what we want is we want to solve for n. So do you see how n is in the denominator of a fraction inside a square root? So that's pretty ugly. So what I've done is I've solved this equation for you where n is by itself. Okay, so I took this piece of the formula and I set that equal to your margin of error, and then I solved it to get just this. That's why it's to the square power, because to undo square rooting you have to square. All right. N is the sample size we're looking for. P hat and Q hat are the sample proportion that we're looking for, and then P hat and Q hat still add up to 1. Z star is the 3 Z stars we memorized the other day. And now E represents your margin of error. Sometimes it's ME, sometimes it's E, it's whatever, you know, it can be either way. So if we read number 3, a researcher wishes to estimate with 95% confidence the proportion of families who own a hot tub. A previous study shows that 40% of those interviewed had a hot tub. But now we want to see if it's changed, right? What's the current proportion? The researcher wishes to be accurate within 2% of the true proportion. So if we think about formula, we don't want this, we don't need this one. What we need is we need n equals p hat q hat parentheses z star over e squared. So that's all the information we need. So we need p hat, q hat, z star, and e. 95% confidence means what's our z star? 1.96. If you've been doing all your practice, you've got that guy memorized, okay? The proportion of families shows, a previous study shows that 40% had a hot tub, which means 0.4 is p hat, which means 1 minus 0.4 or 0.6 is q hat. E, the researcher wishes to be accurate within 2%. This is our margin of error. Okay, be careful, don't put 2 here, it's 0.02, 2% is 0.02. So you're going to have n equals 0.4 times 0.6, 1.96 over 0.02 squared. Okay, so you're going to have 0.4 times 0.6 parentheses 1.96 divided by 0.02 parentheses squared, and we get 2304.96. But let's think about that. This is your sample size. This is how many people you need to ask. Does it make sense to say that you need to ask 0.96 of a person? No, it does not. And this is something that you need to make a note about right now. Even if this decimal is not a decimal that would traditionally round, okay, like if let's say this was 0.16, your answer would still be 2,305 people. Because if you have point anything of a person, you have to ask that whole person. So the smallest sample size you could ask with these parameters to get the right interval would be 2,305 people. Okay? So let's check out a couple more. Okay? The same researcher wishes to obtain the proportion of families who own a jet ski. Using 90% confidence, let's find the minimum sample size necessary if she wants to be accurate within 5%. So 90% confidence means z star equals 1.645. Accurate within 5% means that we're going to have e equals 0.05. All right, but what we've got to figure out is where's the p hat and the q hat. Well, there was a note back here that we didn't touch base on because I don't think it would make sense till we got to this point. If no approximation of p hat is known, then that's when we need to use p hat and q hat are both 0.5. So in this problem, it gave us 40%, so we use 0.4. But if it doesn't provide it to you, then that's when you need to use p hat is 0.5 and q hat is 0.5. All right, and let's look at, so we're gonna have, and I could have actually written these two pieces up here because they're gonna be the same the whole time. So it goes n equals p hat times q hat times z star over, not n, this is e, yes, n, and then this is e squared, okay? So p hat, q hat, z, and z star are gonna remain the same. We wanna talk about how's it changing with our accurate. Accurate within 5%, accurate within 15%, accurate within 2%. So if you want to be 5%, that means you could be plus or minus 5% from your answer. Okay, we're going to get n equals 0.5 times 0.5, 1.645 over 0.05 squared. Plug that guy in your calculator and check to see what you come up with. All right, I came up with 271. Again, you don't practice on your own, then you won't know if you're having trouble typing it in. Okay, so you would need to pull 271 people. What if we want to be accurate within 15%? That means 15 high and 15 low. That's a wide interval, okay? Which means you're not really accurate. You have a 30% window from top to bottom. So if E equals 0.15, then this time we would get n equals 0.5 times 0.5, 1.645 over 0.15 squared, okay? And that comes up to be 30.07, which is 31. That's barely anybody, okay? To be way less accurate, you can ask way less people. What if we say accurate within 2%? Now we want to be really accurate. 2% up, 2% down is going to be a really narrow interval, okay? If we want to be accurate within 2%, we're going to have E equals 0.02. If you do the same equation, but you put 0.02 in the denominator, you're going to come up with, go ahead, type it in. Check to see if you know what you're doing, okay? You should be getting 1692. Look how much that changes. From 5% accuracy, 271 people, to 2% accuracy, right? Accurate within 2% of the true, you need 1,700 people. That's a big jump in sample size because you're narrowing how you want it to be a narrow interval, very accurate. Whereas here, 15% above and below, that's a really wide interval. Okay, so you don't have to ask a lot of people, because you're not going to be accurate, very accurate. You have all sorts of room to be wrong. Now, next problem, last problem for today. A statistician collected a sample of college students and asked them if they spent more than 30 hours a week doing work or studying for their classes. She found the 90% confidence interval, and she's giving you the interval. We need to go backwards and figure out, well, how many students were there? Okay, this is a fun little puzzle. So, if we have 90%, then that means that our z star is going to be what? 1.645. Okay, now, if our interval is 62% to 78%, then really we could write that as 0.62 to 0.78. Do you agree? Okay. To do how many students, we need n equals p hat, q hat, z star over e squared. Right now, all we have is the z star, but we can figure out the p hat, the q hat, and the e. So let's think about it. To get your p hat, it's located where? Where do we keep saying p hat is located? It's right in the middle. What number is right in the middle of these two? From 62 to 78, what number is right in between them? Hopefully you said 70. If you can't figure that out in your head, right, you can always add them up and divide by 2. You could take the average of the two numbers. But right in the middle of 62 and 78 is p hat equals 0.7 or 0.70. Okay, well, from 0.70, how can you get your margin of error? If 70 is in the middle, you go up 8% and you go down 8%. So your margin of error, right, is up 0.08 and down 0.08. So our error is 0.08. It's the distance between p hat and up and p hat and down. So we just used our logic to chat this out. Yeah, this is a challenge problem. This is also a fair challenge problem. Okay, so we're going to have p hat is 0.7, which means q hat is 0.3. Z star we knew from the beginning. E we just figured out is 0.08 squared. Which means that when you put all this in your calculator, you're going to get 88.79, which really means 89 students. If you have questions, jot them down, let me know, and then we'll touch base again. Good job today. Hope you took marvelous notes. See you soon.